This week on the Communicators, a discussion about choices facing Congress, broadcasters, and the President on broadcast spectrum.
Well, this week on the Communicators, we're pleased to introduce you to Dale Hatfield. He is a member of the Commerce Department's Spectrum Management Advisory Committee. He's also a professor at the University of Colorado, and he is considered to be one of the nation's foremost experts on spectrum and spectrum policy. He joins us this week on the Communicators. Professor Hatfield, if we could, a lot of talk here in Washington about spectrum shortage. When you hear that term, what does it mean to you, and is there a spectrum shortage?
That's a really good and very fundamental question. The spectrum, the radio spectrum, is the parts that we are most interested in, is already allocated and mostly assigned to people for various uses. So if I have a new use, maybe a use that has a lot of public interest, it may be very difficult for me to get access to spectrum. On the other hand, if I put a simple receiver out here on the roof of this building and actually looked at the spectrum, it would turn out that a lot of the spectrum, this resource, is not being used all the time, nor in all the places. So in one sense, it's all given out, but that doesn't mean that on a sort of an more instantaneous basis that there's not spectrum available that could be used.
Well, that said, how should spectrum policy reflect the availability of spectrum at this point in your view?
Well, there's a lot of dimensions to it. One, of course, we need to use the spectrum more efficiently. Just as we talk in energy terms of using gasoline more efficiently, making our cars more efficient, we need to be more efficient in our use of the resource. We need to have our transmitters and our receivers and our systems more efficient. And aligned with that, we need to have the incentives for that to occur as well, because things don't happen without the right incentives. So we need to be more efficient in our use of the resource. And then that ties to what I said a moment ago about the fact that a lot of spectrum is not really used a lot of the time, even though it sort of belongs to somebody or is assigned to somebody. And there's some new technologies out there that we can talk about that can help that. But here again, then there's a regulatory process that we have to get through to be able to use spectrum in a more dynamic, less static fashion.
Well, we will get to those, and I want to talk about how you think it can be more efficiently used and what incentives might be possible. But we want to introduce Paul Kirby. He's a senior editor with Telecommunications Reports, which includes their TR Daily bulletin, and he will also be asking you questions.
Dale, as Peter said, you are a member of the CSMAC. It's called the CSMAC, the Commerce Department's Spectrum Management Advisory Committee, and their new 2-year charter, they're called to look at how to help the government free up 500 megahertz of spectrum over the next 10 years, which is a goal of the Obama administration and the FCC. Give us a sense of what you hope the CSMAC can accomplish in the next 2 years in advising the Commerce Department.
Well, there's sort of two parts of that. One is to advise them on what bands would be the most useful for commercial purposes. That's one thing, so we can keep this economic engine that's being provided by the use of spectrum with all these new devices, keep that moving. So we want to help them in that regard. And then help them in terms of what I just said a moment ago, and that is to try to get the incentives right, to provide mechanisms, so the suggestions, the ways of ameliorating or reducing interference issues, so that our critical national defense and our critical governmental needs for spectrum can go forward and still meet, as I said, our need for this vast amount of new spectrum to support commercial applications and public safety too.
Now, we talk about getting the incentives right. One thing in the past you have said could work, and in fact the CSMAC has looked at in the past, is spectrum fees for licensees to provide incentives to use the spectrum more efficiently. Give us a sense of why you think that could work.
Well, it works in both sides of the both the commercial sides uses of spectrum and governmental. Is that one of the problems we have in spectrum is a lot of people have the spectrum and they have not had to pay for it, don't pay for it, and it's like anything else you get for free. There's not as much incentive for you to free up the spectrum and maybe make it available to others. So there's different forms of incentives, but economic incentives, of course, is what drives a lot of our free enterprise system, our capitalist system, and having people pay for the spectrum they consume as it gets more and more valuable seems like something we should be looking at. And I myself am generally favorable to having government agencies pay for the spectrum that they use so that they're, as I indicated, more sensitive to whether they're using it efficiently or not. If you're paying something, you'll be more efficient. If I gave gasoline away, I wouldn't care where I drove. I wouldn't care what size of car I drove. But if I'm paying for the gasoline, then I'm more careful choosing where to go and what vehicle I might buy. So it's the same sort of notion, making people sensitive to the value of the resources that they're consuming.
Dale, we talk about figuring out a way so federal government agencies can use spectrum more efficiently. One of the things the CSMAC has looked at is an Office of Management and Budget circular to try to incentivize those agencies to use spectrum more efficiently by basically, when they plan new systems, looking at what the cost of the system would be. Can you give us a sense of what that's about and why that might be effective?
Yes, as you suggest, the OMB, of course, does have the power to look at systems and recommend or not recommend their approval based upon the budgetary impact. Traditionally, that budgetary impact, though, has only just been the cost of the building and operating the equipment, and has not taken into account explicitly the value of the spectrum that may be used in providing meeting the mission of that equipment. So I haven't said that very well, but basically a design engineer sitting down and doing a design is focused on making it perform to meet certain specifications and may not be as conscious as they should be of the value of this resource, the value of the spectrum as perhaps they should be. So the idea is for them to do some calculations to show what the value of the spectrum they're going to use, and then to make some trade-offs. In other words, is it really worth this extra little bit of performance if it's going to cost an awful lot in terms of the amount of spectrum consumed, spectrum that could be used in some other high-value application as well?
Well, Professor Hatfield, is that feasible? Is that something that could happen where the agencies are charged essentially for their spectrum use?
Yes, I believe so. The United Kingdom has had some experience on that. There are some issues, of course, but I believe either explicitly taking into account the value of the spectrum, in other words, by charging a fee, or by having a process that the design people have to go through that takes implicit account of the value of the spectrum. I believe both of those are indeed feasible.
So how much of the spectrum does the federal government currently control for its own use?
Well, that number is hard to get, and I'm not sure sitting here I can give you the right number. But let me tell you the difficulties. Is a lot of the spectrum is already shared, so some spectrum is already shared. So there's a little bit of difficulty counting there. And then the government tends to use an awful lot of spectrum that's very high in frequency for things like radars and satellite communications and stuff like that. And the spectrum that's most useful, or potentially the most useful for a lot of commercial purposes, is lower in frequency. And so I can't quote you right here, sitting here, the exact percentage, but it's a significant amount if you include the higher frequencies as well.
Let's talk about some other spectrum that's gotten a lot of attention. It's spectrum used by TV broadcasters. The FCC wants to voluntarily reallocate 120 megahertz of TV spectrum that would be part of the 500 megahertz that they want to try to free up for wireless broadband. You're a technologist. From a technical standpoint, how difficult will that be? There are a lot of questions still to be answered. How do you repack channels to free up spectrum and have large enough blocks that wireless carriers want and need? Give us a sense of how you see that working out.
Well, the problem is, part of the problem is, as I indicated earlier, spectrum is not used uniformly. Spectrum tends to be, of course, used the most and most valuable in urban areas. So in the case of television, it's in the northeast corridor where people are packed closely together, and television stations have to be packed together. And freeing enough spectrum in those areas, those critical areas, for reallocation, that's where it's really tough. So the technical analyses are very challenging. And my own sense, and this is, I've not done the detailed engineering studies myself, but my own sense that it's going to be a challenge to come up with significant amounts of spectrum in the urban areas where it's needed the most for the cellular phone type applications. Where it can be very useful, I think, is in more rural areas of the country where we can free up with the new technology and repacking. We could free up some fairly significant amounts there. The question there is whether you can get device manufacturers, that market turns out to be attractive enough that we can drive the prices of the devices down to make that attractive spectrum for use in rural areas where it's so difficult to get fiber in and so forth.
Dale Hatfield, going back to the urban congestion issue, are we almost to the crisis point when it comes to spectrum availability in the urban areas, much like traffic is at a standstill in many urban areas?
There sure are some challenges. I'm a little cautious to as to the choice of words, but clearly in major urban areas, the rapid growth of devices like iPads and so forth that use a lot of, especially video. As an engineer, your voice conversation, of course, doesn't use much of the resource. But when you start talking about doing a lot of video and that sort of activity, it really increases the bandwidth. And the more of these devices come online, we just see them all the time, that really puts upward pressure in the urban areas. And the studies that I've done suggest that while there are certain efficiency measurements that we can get in terms of getting more video through a given slice of spectrum, that's not going to be the long-term answer. And what we have to do is use spectrum more intensely in the geographic sense. And what I mean by that is when cellular started out, it used great big cells, so one conversation sort of occupied a large area. But as the market's grown, the cellular carriers have continued to shrink the size of those cells down smaller so that they can use the same spectrum over and over again in the same market. So what I see having to happen here in the short to medium term is we're going to have to use spectrum more efficiently by going to smaller and smaller cells. And these are called pico cells and femto cells and devices like that result in, including Wi-Fi, that only use a small amount of geographic spectrum. They only use spectrum over a small geographic area so that we can pack in more people. So I think that's the long-term solution there. It doesn't solve problems for all types of systems, however. But that seems to me, going forward, is a major area that we're going to have to focus on.
You're watching The Communicators, C-SPAN's weekly look at telecommunications and telecommunications policy. Our guest, Dale Hatfield, is joining us from Denver. He's a professor at the University of Colorado, and he is also a member of the Commerce Department's Spectrum Management Advisory Committee, CSMAC. And he is also the former Engineering and Technology Chief at the Federal Communications Commission. He has about 50 years of experience in telecommunications policies, particularly spectrum issues, and he is considered one of the leading experts on spectrum in the nation. Paul Kirby of Telecommunications Reports is our guest reporter.
Dale, we're talking about spectrum efficiency. One of the things you made a reference to earlier, I think, was dynamic spectrum access technology. That's technology that actually started with the Defense Department as they tried to make basically reuse the spectrum and improve its efficiency, I believe, by 10 times. Give us a sense of what this would do and how this could help going forward.
Oh, I think it could help enormously, because as I indicated, if I did a sort of a conceptual experiment, went up to the roof of this building here in the Denver area right now, and had a really good receiver and could pick up signals in a large swath of spectrum, it would turn out that there's large amounts of spectrum here as I sit that's not being used, while at the same time there are people who may need spectrum. So the idea is that when spectrum is temporarily not being used by somebody else could use it, and we call that dynamic spectrum assignment. So rather than making an assignment that runs for years but is only used a few minutes a day, it would mean that, or perhaps only a few hours a day, that means that somebody else, when their person is not using it, when they're not on the air, somebody else could use it. If we did that, then we could raise the average use from maybe 5% or something like that up significantly higher, so that everybody has more opportunity to use the resource. But that requires then arrangements for the spectrum to be shared. And that's the rub. People who have spectrum that may not be used very heavily are often reluctant to allow their spectrum to be shared by somebody else on a short-term basis, for a number of reasons.
Yes, and that is the rub. The FCC has put out an item looking at dynamic spectrum access and seeking comments. Years ago, as you're aware, the FCC looked at something called interference temperatures, and basically the idea would be it would allow folks to use spectrum that wasn't used, perhaps below the noise floor. That didn't work. That didn't go anywhere. As you said, politically it's difficult, and kind of from a business standpoint, incumbents don't like anything that sounds like forced sharing, if you will. Why technologists like to look at dynamic spectrum access, perhaps in unlicensed spectrum. How realistic is it for that to be implemented in licensed bands, do you think?
It comes down again to incentives. And as spectrum grows more valuable, if I'm holding spectrum that I'm not using all the time, hopefully the marketplace would work. Somebody would come to me and they say, Dale, I see that you're using your spectrum heavily during the week, but not so much on weekends, and I want to do some electronic news gathering in Boulder, for example, on the weekends. I'm making this up entirely, and I'd like to lease some spectrum from you and use it on a dynamic basis. So that would provide economic incentives for me to do that, and it could be even on a shorter term basis. But there are costs of trying to make those arrangements, and more fundamentally, spectrum is a resource that has some troublesome characteristics the way we manage it now. For example, if I agree to allow somebody to use my spectrum and what they use it for turns out to be wildly successful, then what the person who's leasing it may go to the FCC and say, look, this is obviously a much better use of the spectrum than what Dale's doing, so reallocate the spectrum to us. So my economist-oriented friends would say what's happening here is the rights to use spectrum, the rights that sort of look like property rights, are not very strong. So it may mean that I have to give up spectrum if I allow somebody to share it. These are the sort of negative incentives to sharing that we need to overcome. We need to provide more positive incentives so people, I think using your word, Paul, voluntarily enter into sharing agreements.
Now, there's something we haven't talked about yet that's near and dear to your heart, and you bring up in just about any time you talk, and that's called receiver standards. Right now, the FCC will regulate transmitters, but there are not detailed standards on receivers. That issue's come up recently in the light squared proceeding, where you have GPS receivers and you have light squared and adjacent spectrum. Can you give us a sense of why you think receiver standards make sense, and do you think they're more likely, perhaps, coming down the road in light of light squared, TV white spaces preceding the FCC, where again, receivers, there was a lot of focus on the receivers?
Let me just say initially, there's no doubt whatsoever in my mind that over time we have to tighten up on receivers. Now, having said that, let me back up a little bit and give a little bit of background. Most people, if they have a receiver in their house and they get some interference from some other source, they assume that it's the source, this other station or something that they hear, that's causing the interference. But that other station, that other person, that other device may be operating completely legally in its band. But what happens, because the receiver that I have is receiving outside the band that I'm assigned or I'm supposed to be using, I receive interference. So one of the hardest things I've had over the years is getting people, especially non-technical people, to understand that transmitters, you have to have transmitters that don't squander spectrum. But equally, you have to have receivers that are not so wide, that don't pick up so much extraneous stuff that you inhibit the ability of people on either side, on channels on either side, from using using that spectrum. Because, in other words, the receiver is poor, is not selective enough, and therefore ends up preventing us from using very, very valuable spectrum. And here, as a nation, we can't continue, in my mind, without doing something and continue our growth based upon this electronic revolution here, unless we do something about the poor receivers that may get out there in large numbers, and as I said, preclude us from using spectrum more efficiently.
Professor Hatfield, is the technology available to make those receivers more efficient?
Oh, certainly. And I don't mean to make light of this. There are cost trade-off issues. In other words, the tighter I make my receiver, the less susceptible it is to interference. There's a cost impact. But a lot of the studies that I've seen going back 30 or 40 years, in some cases, the additional cost of the device is so small as to be de minimis, and therefore there could be huge benefits from better receivers at a low price. Now, let me say, in defense of like consumer manufacturers of consumer devices, they're sometimes in an extremely competitive environment. And when we say, oh, it only costs a dime more on a $100 product, in some cases that dime, they have to be careful. That's the reason I think that you need some government action, so everybody then is under some pressure to design their receivers to take into account the value of the spectrum, that you can't have people that sort of ignore it and put out low quality receivers that get out in such large numbers that were effectively precluded from using the adjacent bandwidth.
Well, one of the issues with Light Squared, and we just spoke with Sanjeev Ahuja, the chairman and CEO of Light Squared, a few weeks ago here on the Communicators, is the interference issue. What's your opinion of the Light Squared model?
Well, I here again, I've not been intimately involved in that, and that's an area of such high intense political debate right now that I'm a little hesitant to go too far in reaching conclusions regarding their specific proposal and their specific technology. But my belief is it really does illustrate the importance of getting the receivers designed properly and not allowing them to proliferate. And having long years of experience, I feel that the problems can be solved through the improvements in technology, either by retrofitting some of the existing devices or in improvements in devices as they turn over naturally in the marketplace.
As a technologist, is it frustrating to you when you have proceedings where the TV white spaces, the Light Squared proceeding, where you have both sides just get engineers? It's kind of like expert witnesses in a trial where you'll have someone say this and it's like, well, we have a guy to say this, and then they just fight, or they can't decide the key issue, what's harmful interference. Is it frustrating that people kind of, if you will, some people will kind of take their engineers to make their case, their political cases, if you will? Does that give the engineers, the engineering profession, a bad name, do you think?
Well, it certainly is. The whole thing is troublesome. What bothers me particularly is that where issues get escalated up into the Congress into a political debate before the engineers have had a chance to try to sit down and fully work out the technical the technical issues. Because once it reaches that, because almost all the services we are talking about, and not specifically even Light Squared, but a lot of these, people make very good claims. If I receive interference, it's going to harm my ability to do something that's in the public interest. And once the debate is going on at that level about that sort of thing, that my service is so critical, it can't be interfered with at all. You're beyond what the engineers can do. The engineers can contribute so much if you keep them as much out of the political environment for as long as possible and let them figure things out. Because often when you get engineers in a room together, the engineer will say, well, gee, if you would just tweak this over here a little bit, I'll tweak this over here a little bit, and we can solve this problem. But once it gets into the political domain with so much money involved and so forth, then it's very difficult to work out, you know, some of those types of solutions.
So if you lock the engineers in a room with some pizzas, you'd be okay. It's just when it gets up to the hill and the attorneys get involved that you get a bit of a problem. Is that? I don't want to get you in trouble.
No, what I'm saying, yeah, thank you, Paul. What I'm saying is you want to try to narrow. I mean, Congress has an obvious important role in deciding how much, you know, ultimately how much risk we want to take in certain areas. But what you want to do, it seems, is get the engineer to narrow the issues that Congress has to address, and narrow them in a way, and then get them expressed in a clear thing where the trade-offs and so forth are clear. And like I say, even maybe solving problems before they have to be even escalated there. And that's what the engineering ethos, the engineer working together can sometimes do. But I'm not arguing at all that there's not an important role for Congress. Some of these issues with major blocks for this spectrum versus something else, ultimately it comes down to important decisions that should be in the hands of the Congress. But on the other hand, we ought to try to do everything we can to narrow the issues, to work out things so it doesn't have to escalate into where we get these terrible battles going on between different stakeholder groups.
Dale Hatfield, should net neutrality guidelines apply to the wireless industry as heavily as it is being thought to applied to the wireline industry?
Net neutrality, I was sitting here thinking of spectrum, and net neutrality is an interesting issue. The argument that the wireless carriers have, the wireless providers have, is that people who don't use their channels wisely, people who have applications, for example, that consume an awful lot of bandwidth, you know, that takes bandwidth. You know, if we're sitting in this room and there's a Wi-Fi access point and I started doing a lot of video, I'm going to slow down the performance that you receive and the performance that received somebody in the next room over here and so forth. And so that's much more true than it is in the wired world. So it's pretty clear to me that the wireless providers have to have some flexibility to manage their network. The key to it, though, is you don't want them to do it in a way that, in my opinion, you don't want them to do it in a way that's discriminatory in the sense that it slows down other people's applications, doesn't slow down the ones that they have a proprietary interest in. So my answer is yes, I think you need to cut the wireless carriers a little bit more slack, but you also at the same time need to be careful that in doing so that they're not unfairly disadvantaging potential competitors. Now that depends upon how competitive the market is, of course.
Unfortunately, Dale Hatfield, we are out of time. I would recommend to our viewers to type Dale Hatfield into a search engine. You can get his background. You can also go to the University of Colorado website to get some background information on him. Professor Hatfield, thank you for being on the Communicators, and I hope you can come back.
Thank you. I'd be happy to do so.
And as always, Paul Kirby, one of our regular guest reporters here on the Communicators. He's with Telecommunications Reports, and that includes their TR Daily publication, which comes out on a daily basis. Thank you.
Thank you.